this is the solution to the first problem on the exam. I've drawn the free body diagram for the piece of cork, and since we know it's in equilibrium, we can apply Newton's second law and set it equal to 0 because we know the cork is not accelerating, which leads us to B minus WC, which is the weight of the cork, minus F sub S, which is the reading of the spring or the force of the spring, to equal 0. We know that the weight of the cork is the density of the cork times the volume times G. Notice that these two terms gives us the mass of the cork. We also know that the buoyant force is given by the density of the fluid, in this case water, times the volume displaced, which should be the same volume as the cork, times G. And this leads us to the term Vg equaling the buoyant force over the density of water. So now we have B minus density of cork, volume G, minus Fs equal 0. And notice that from this equation that B equals Wc plus Fs. So if I replace this B by Wc plus Fs and this Vg by B over W, I get something that looks like B minus rho C. Instead of Vg, we have B over rho W minus Fs equal 0. And now if we continue and we plug in what B is the weight of the cork plus the force of the spring minus the density of the cork over the density of water times B, which is again the weight of the cork plus the reading of the spring, minus Fs. This equals 0. Notice that the Fs's cancel out, and we have W sub C minus rho C over rho W times W sub C plus F sub S equals 0. And if I move this second term over to the other side, we get that Wc equals rho C over rho W times Wc plus Fs. And now if I multiply everything by rho W, I get rho C equals Wc times rho W, and then divided by this term W sub C plus F sub S, and we can reorganize this and say that this is Wc over Wc plus F sub S all times W water. So now we found the density of the cork as a ratio of the weights and the forces times the density of water, and if we plug in the values we know, we get the following. We're given that the weight of the cork is 0.285 newtons, so 0.285 newtons over 0.285 plus 0.855 newtons for the reading on the spring times the density of water, which is 1,000 kilograms per meters cubed. This gives us a density of the cork to be 250 kilograms per meters cubed.